Hi, my name is Leonard, and welcome to Datature Tutorials. Today we're going to be talking about how to train an object detection model. In general, object detection models are used to predict bounding boxes around objects of interest in an image. In our case, we want to detect various types of vehicles and put bounding boxes around each of these vehicles within an image. To get started with training an object detection model, we'll first want to upload our visual assets. We can go to the dataset page and upload assets there, either through the rectangular box or through external buckets. As you can see, we've already uploaded some images prior, and the next step will be to go ahead and annotate them. There's one image in the top left right there that hasn't been annotated, so we'll go ahead and select that image, which will bring us to the annotator. To annotate bounding boxes on the annotator, what you have to do is go ahead and select the appropriate tag, which we can see on the bottom right, and then draw a bounding box with the rectangle tool, or use some of our intelligent tools, such as IntelliBrush, or even our latest feature, IntelliMatch. To efficiently annotate bounding boxes, what we can do with IntelliMatch is annotate one image, which will act as a query annotation. This will then prompt the tool to provide suggestions on other similar annotations in the image, and you can approve, edit, and even further query the tool in order to bring about better annotation predictions. Once we're happy with the annotations provided, we can go ahead with the model training step and use this training data to actually train a model. To get started, we'll go to the workflow page and select to create a new workflow. We'll select object detection as our task. And then for model size, we want to opt for a smaller model, as we'll have to process many images from this aerial dataset. So we want something that is more portable and more capable of processing many images at a time. With that in mind, we'll also be opting for balanced performance, as these objects are quite small, so we don't want the model to not be able to pick up any objects, and so we still want to maintain some level of accuracy. Once we have a workflow set up, we'll want to go in and edit the various hyperparameters to suit our needs. Particularly for this dataset, we also want to activate something called the sliding window setup. When we train the model without sliding window, it's possible that because the objects are so small, the model may not even be able to pick up these objects due to the image being downsized to the model's output, and as such, the objects being reduced to maybe a few pixels only on the image, or even less than a pixel. As such, sliding window operates by cropping the individual areas of an image and slicing them up such that a model is able to look at a single crop at a time and allow for the object's relative size in an image to be larger and more able to be picked up by the model. In this case, the sliding window setup has a few different options. The sliding window crop size, which is the actual crop that the model will be looking at. In this case, we've selected 640 by 640. In this example, there's also the overlap ratio, which means that there is some relative proportion of each sliding window that will overlap with another window, such that the model won't miss any objects that are split between crops. We also have an annotation completeness threshold, which will filter out annotations that are incomplete due to this slicing mechanism, and as well as disregarding or including crops with no annotations within them. To actually visualize what this would look like, we have a tool at the bottom called the Preview Sliding Window tool, and we can go ahead and select that. As we can see, this originally rectangular, very large aerial image can now be split up into 8 different crops, and we can see that in the individual crops themselves, the objects will now appear larger because the model is focusing on a specific crop. And the overlapping mechanism also shows that some objects are repeated, so that if they're sliced off in one crop, they'll be properly represented in another to maintain some semblance of the original dataset. Next, we can look at the augmentation block, and we can alter hyperparameters here. We might want to include augmentations that match the natural space that we're working in, which is the aerial imagery space. So we can include things like brightness and contrast to account for more variation in weather or lighting conditions based on the time of day or what's happening. Next, we can look at the model block in order to alter individual training parameters there, or even create a new model, such as the YOLOv8 medium 1280 by 1280. The goal here being to use a higher, more robust model in order to analyze the individual crops. Once we're satisfied with the hyperparameters, we can go ahead and select Run Training. We'll select for highest accuracy as our checkpoint strategy, and we can also reduce the evaluation interval to better suit our computational needs. We'll also select Datature Cloud as our hardware configuration in order to run the training on the cloud. And finally, once we're happy with these settings, we can select to start training. Let's hop over to a training that is already completed. Once we've clicked in, we will be able to see the loss metrics for an object detection model that are typical, such as the focal loss, classification loss, box loss, etc. We can also look at more visual representations rather than quantitative measurements in order to see whether the model is training well. As we can drag the evaluation checkpoint along to see how the training progresses, we can see that more and more cars and various vehicles are being detected. And we can even zoom in to see how they compare directly. And as we can see, a lot of these vehicles are actually being picked up pretty well. We can also go to the confusion matrix to determine which categories are performing better than others. As we can see, car is performing quite well with a 96% accuracy, whereas some other categories such as truck or bus are not performing as well. However, with this in mind, we can still opt to export this artifact and deploy the model. So we can navigate to the artifacts page, select the corresponding artifact and either choose to export the artifact or create a deployment. In this case, we'll select export artifact, which will bring us to the various types of frameworks that this model can support. Thereafter, we can generate the artifact and download it and deploy it as needed. Now that we've trained and deployed this model, you'll now be able to analyze aerial images and pick out vehicles of various types on your images.